Good morning, my dear students. Today we are going to study an interesting topic. Are you all ready? I welcome you all to my class. You have already learned about solutions and suspensions in your previous classes. Are there any mixtures which are neither of these? Yes, definitely there are mixtures which are neither solutions nor suspensions. Today we are going to discuss about such mixtures. First of all, I will give you some examples that you are already familiar with. You have to listen carefully to these examples and answer me whether these mixtures are solutions or suspensions or something else. The examples are milk, smoke, fog, soap lather, foam, gemstones, jellies, butter, cheese, milk, mayonnaise, soft drinks, rice starch water. Okay, all these examples are familiar to you. Can you tell me whether these mixtures are solutions? Are they solutions? No. Are they suspensions? No. Then what are they? Yes, they are colloids. What is a colloid? A colloid is a mixture in which one substance, the dispersed phase, is evenly distributed in another substance, the dispersion medium, with particle sizes between 1 to 1000 nanometers. So we can say that colloidal mixtures act as an intermediate state between solutions and suspensions. The size of the colloidal particles must be between 1 nanometer and 1000 nanometer. There are two main components in the case of a colloid, and they are dispersed phase and dispersion medium. We cannot see the particles of colloids with our naked eyes. They do not settle down and cannot be filtered using an ordinary filter paper. The particles are big enough to scatter the beam of light so that the path of light is visible. What is dispersed phase? Dispersed phase means the substance that is distributed or dispersed throughout the dispersion medium. Or simply we can say that dispersed phase is a substance which is dispersed or distributed. It can be solid, liquid or gas. What is dispersion medium? The substance on which dispersion takes place, or the substance in which the dispersed phase is distributed, or the substance in which dispersion takes place. It can be also solid, liquid or gas. When you take the example of milk, you can see that dispersed phase is a fat globules dissolved in it, and dispersion medium is water, and dispersion medium is a continuous phase. Okay. In the case of smoke, we can see that dispersed phase is a solid dust particles distributed in smoke, whereas the dispersion medium is air, which is a continuous phase. Now take a look at this table. This table shows the comparison between solutions, suspensions and colloids. In the case of solution, look, the size of the particles will be between 0.1 to 1 nanometer, and any type of particles can be there. Ions, atoms and small molecules, means the particles are very smaller in size. There is no scattering. Since there is no scattering, there is no Tyndall effect. They are stable molecules or stable particles. Particles cannot be filtered, and solution is a homogeneous mixture. In the case of colloids and suspensions, the particles are very large. In the case of suspension, they are large particles or aggregates. In the case of colloids, look, the size of the particles is between 1 nanometer and 1000 nanometer. Since it can scatter the beam of light, it exhibits Tyndall effect. it is stable, but we cannot separate using an ordinary filter paper. But the particles can be separated by techniques such as centrifugation. It is a heterogeneous mixture. In the case of suspension, the size of the particles means it will be about 1000 nanometer, and it exhibits Tyndall effect because it scatters a beam of light passing through it. Suspensions are unstable mixtures and they are heterogeneous mixtures. Particles can be separated by using a normal or ordinary filter paper because the particles are bigger in size. Okay, this is another picture just to convey the topic more clearly. It is also, in the first image, there is a glass which is filled with water and what salt is dissolved in it, means salt solution. In the second glass, there is flour dissolved in water, suspended in water. And in the third glass, it is milk. So there scattering of light is depicted here, and we can see scattering or the beam of light will be visible only through suspensions and colloids. In the case of solution, we cannot see the path of light, or the path of light is not visible. This is also an experiment to illustrate that when a beam of light is passed through the three beakers, only the beam of light can be visible through colloids and suspensions. This is another table showing the classification of colloids. Means based on the physical state of the dispersed phase and dispersion medium, colloids can be classified into 8 different types. Just take a look at this table. There is nothing very simple. You just study the names of the colloids. Means when the dispersed phase is solid and the dispersion medium is solid, the colloid's name is known as solid salt, and some examples are also given. When it is solid liquid, the colloid's name is known as salt. Solid gas, aerosol. Liquid solid, gel. Liquid emulsion. Liquid gas, aerosol. Gas solid salt. Gas liquid foam. Okay, just study these examples also. Just go through these examples also based on the interaction. So first we have studied that based on the state of the dispersed phase and dispersion medium, colloids can be classified into 8 different types. Based on the interaction between the dispersed phase and dispersion medium, we can classify colloids into 2 different types: lyophilic colloids and lyophobic colloids. Lyophilic colloids means they are solvent loving, means there is a strong force of attraction or interaction between the dispersed phase and the dispersion medium, and they are reversible, they are stable colloids. Okay, examples are given: gelatin, starch solution, rubber in water. On the other hand, lyophobic colloids are solvent hating colloids. There is a weak force of attraction or interaction between the dispersed phase and the dispersion medium. They are difficult to form and they are irreversible, unstable, etc. Examples: salts of metals, gold salt, silver salt, sulfur salt. Then based on the size, they can be classified into multimolecular colloids and macromolecular colloids and associated colloids. Multimolecular colloids means the size of the particles ranges from 1 to 1000 nanometer because they are smaller in size. Compared to macromolecular colloids, they are smaller in size. Example: gold salt, sulfur salt. Macromolecular colloids means they are greater than, the size of the particles will be greater than 100 nanometer. They are bigger in size compared to multimolecular colloids, and examples are starch, proteins, carbohydrates, polymers, etc. Associated colloids are the colloids that we are very much familiar with. That means soaps and detergents. They form aggregates of surfactant molecules. In low concentrations, surfactants behave as individual molecules. At higher concentrations, they aggregate into structures called micelles. Okay, Their size will be from 10 to 100 nanometer. Soaps and detergents which helps us to clean oil, dirt from our clothes are examples of associated colloids. We are also using colloids in our day-to-day life. No, the soft drinks that we drink, milk, blood, whipped cream, shaving cream, paint, ink, mayonnaise, okay, fog, smoke, mist, cloud. So we are seeing colloids everywhere in our day-to-day life. So colloids play an important role in our day-to-day life. It helps to contribute to the texture, stability and functionality of many substances that we use daily. I hope you all understood the class. Thank you.